Good morning friends. In this video under stream gauging we shall discuss various techniques of measurement of velocity and dilution technique for getting the discharge or flow in the river. So in the previous video we shall discuss regarding area velocity method. So under this river section is divided into different strips or different cross-sectional area is determined knowing the width and knowing the depth, and then multiplying it with the help of velocity one can get the discharge. Now how to find out the velocity in the river? So different instruments are used for determination of velocity in the river. So price current meter, one of the well-known instrument, is used for determination of velocity. In the government departments, in the CWPRAs, normally this price current meter is used for getting the velocity. The velocity of flow at any point in the open channel can be most accurately and conveniently determined by means of a mechanical device named as current meter. So velocity in the river, velocity of flow in the river at any point, wherever you want, you can get the velocity with the help of this first price current meter, or you can say current meter. So coming to price current meter, it is a differential type of meter and consists of a horizontal wheel carries a series of cups that rotate on a vertical axis. In this meter, half of the cups bear convex and half as concave. There is a tail vane and counterweight at bottom to balance the meter and keep it steady. So price current meter, it is called as a differential current meter because based on the difference it gives the velocity. So it is called as differential pressure difference. It is called as price current meter. So these are the component parts of current meter. So here you can see this is the schematic of price current meter. It consists of the sounding weight at the bottom to make it truly vertical. To balance it, the sounding weight is provided at the bottom, and here this is the cup assembly. These are the cups which are provided on vertical axis. Half of the cups are concave and half of the cups are convex. So here you can see counting mechanism is provided adjacent to this cups. This is electrical connection, and here this is the hoist. Hoist is provided to attach it to the boat because while taking the velocity measurement in the river, it is attached to the boat and then it's taken to a certain point. And here you can see this is the stabilizing point pin. It provides stability to this price current meter. Now working of this current meter, when the meter is lowered in the water and when it faces the current of water in the channel, the wheel rotates. So prior to this, how it is fixed to the boat. So while measuring the velocity in the river or in the flow, directly you cannot go with the current meter in the flow. So it is attached to the river because river cross section is very big. During the flood also with the help of current meter you can find out the velocity. So this current meter, it is attached to the bottom of the boat and boat is taken to that point. It is made stagnant and then measurements are made. When the meter is lowered in the water and when it faces the current of water in the channel, the wheel rotates. To keep the meter facing the direction of flow, a tail is attached. Here tail, or you can say sounding weight, is there. This tail aligns the meter in the direction of flow. The meter is also fitted with a streamline weight, fish weight, called as fish weight, which keeps the meter in a vertical position. The rate of rotation of the wheel depends on the velocity of flow. A dry battery is kept on the shore or in a boat and an electric current is passed to the wheel from it. So it works on the electric current. Our method of measuring the velocity. So already we have discussed in case of area velocity method, the cross section of the river, it is divided into sub sections. Different stretches are made, different widths are made. Then knowing the width, as we have discussed, L1, L2, L3, or W1, W2, W3, these are the various widths, and then depth is measured, average depth is measured at the center. So knowing the width and knowing the depth, you can find out the area. So at each and every section, we have to find out the velocity, isn't it, for getting the accurate velocity, or you can say average velocity. So normal rule is that, or normally the velocity is measured in each and every cross section or subsection. The velocity is measured at 0.6 d, not for complete depth or not at the surface. So from the surface, the current meter is lowered up to a depth of 0.6 times of depth, and then velocity is measured, and that velocity is treated as a mean velocity. Sometimes it is multiplied with the help of coefficient. Normally it is 0.96. So directly whatever velocity you will get, it will not be direct velocity, it should be multiplied with the help of 0.96, means little bit variation will be there. Sometimes instead of measuring the velocity at 0.6 d, it can be measured at 0.2 d or 0.8 d from the surface. 0.2 times of the total depth from the surface, or 0.8 times total depth from the surface, and then average of these two is taken and it is treated as a mean velocity. Right? How velocity is measured? At each and every subsection velocity is measured. So now at which point it should be measured? So from the surface of water, it should be measured at 0.6 times that depth of that section, whatever depth you have measured. So for L1, depth will be Y1, so 0.6 times Y1, or you can say D1, the current meter should be lower, and it will be average velocity. Sometimes instead of taking only single point observation, two observations are made, one at 0.2 d and second at 0.8 d. Average of these two is taken and it is treated as a average velocity for getting velocity of that cross section or that subsection. The mean of these two rings gives mean velocity of flow at that section. Generally, mean velocity of flow at a section is obtained by keeping the meter at 0.6 d. General observation is that it is taken at 0.6 times of d. In the observed velocity, corrections are made for any obliquity of the current with the cross section, and also for that it is necessary to conduct vertical velocity distribution experiment at each side to decide point of average velocity. So now how velocity is measured with the current meter? So current meter is lowered with the help of boat. Boat is used. With the help of boat, the current meter is taken to a certain point, and then velocity is measured at each and every subsection. Normally, if single point observation is there, velocity is measured at 0.6 times of depth of that stretch. Or sometimes two observations are taken, one is at 0.2 d and second is 0.6 d. Average of these two is taken and it is treated as a velocity. So knowing the cross section, knowing the velocity, one can find out the discharge in the river. Now how one can get the velocity? We have discussed it should be measured at this and that. The number of rotations are measured and correlated to velocity using the formula. So directly we will not get the velocity with the help of current meter. So this relationship use V equals to A plus BN. So here A and B, these are the price current meter constant which are given by the manufacturer, and N is the number of rotations. Revolutions. Number of revolutions are measured, revolution per second or rotation per second. These are measured. So knowing A, knowing B and knowing A, one can find out the velocity. This is regarding determination of velocity with the help of current meter. Sometimes with the help of conventional techniques also we can find out the velocity, but these techniques are used for the small channels, shallow channels. So first technique is the float. A float is a distinguishable article that floats on the water surface, such as a wooden log, a plastic bottle partly filled with water, or branch of a tree, or sometimes piece of paper, you can say this paper, right, is used. आणि तुम्ही जर तुमचे जुने दिवस आठवले, समजा शाळेमध्ये असताना आपण जेव्हा शाळेतनं घर जायचं, जर का आपल्या रस्त्यामध्ये ओढा असेल, ओहोळ असेल, तर आपण काय करतो, त्याच्यामध्ये काहीतरी पान टाकायचं, आपलं पान कुठपर्यंत जातं. कधी कधी होड्या बनवायची, राईट, आणि त्या होड्या मग एका पॉईंटपासून तुझ्या दॅट टेक्निक इज यूज फॉर डिटर्मिनेशन ऑफ व्हेलॉसिटी ऑफ फ्लो. Surface or near surface floats are used for stream flow measurement, which are wooden cylindrical rods of nearly 0.5 meter length. Sometimes wooden rods are also used. Special types of rods are used for measurement of velocity also. They are shaped such that they float nearly vertically with 1/3 of the length protruding above the water surface. Protruding means projecting above the water surface. So in case of these wooden rods, sometimes wooden rods are used for measurement of velocity. So these wooden rods, these rods are painted rods, and in case of these rods, sometimes weight is provided from the bottom so that they will maintain the vertical in the flow. And in case of these rods, the weight is arranged or adjusted in such a way that 0.94 times depth will remain underwater, and rest of the rod, that is, you can say about 4 centimeter, it will be above the water. It will remain above the water for making the observation. So here you can see, you can see the wooden रॉडही म्हणू शकता, उडी म्हणू शकता. हिअर फ्लॅग लावलेला असतो, कलर्ड फ्लॅग, म्हणजे आपल्याला समजतं ते हाऊ इट इज मूविंग अँड वेअर इज द पोझिशन. समटाइम दिस टाइप्स ऑफ रॉड्स are used, wooden rods are used, and these are pelted with the water bound colors. At the bottom you'll find this weight so that it will be vertical, and normally 3 to 4 centimeter will remain above the water so that it will be visible to the observer. And these are used for, and in case of this distance travel divided by time will give you velocity. Simple technique is used. So the floats are painted in bright colors for easy identification in muddy or turbulent water. For a float measurement, 2 cross sections. So now we shall discuss the procedure how velocity is measured with the help of float. So what is done for a float measurement? 2 cross sections sufficiently far apart on a straight reach of river are selected. So here you have to select 2 cross sections at a certain distance apart. The upstream and downstream cross section should be sufficiently far apart for accurate measurement of float travel time, 3 to 5 times the width of the river or channel, and which will take minimum 20 seconds for travel. Travel time should be minimum 20 seconds. Both the cross sections should be clearly marked. First section and second section, it should be clearly marked, placing markers so that the exact time when the float crosses the cross section can be identified. An observer each is positioned at upstream and downstream ends of the ridge such that they are visible to each other. So there will be 2 cross section. So one observer will be at the x1 cross section, and second will be at x2 cross section. The downstream observer acts as a timekeeper. The downstream observer will record the time. Floats may be tossed from a bridge or cableway. If there is no such a facility, then they can be thrown in the water from the river bank. Normally this is done. This is conventional way. So how floats are thrown into the water or tossed into the water? So in case wherever bridge facilities there or cableways there, from that waves or they are thrown into the water, or sometimes from the edge of the river it can be thrown into the water. When the float crosses the upstream cross section, the upstream observer gives a signal. म्हणजे आपण एकदा ते एखाद्या कुठून तरी आपण तो एजवरनं टाकायचं, किंवा ब्रिज असलं तर बीचवरनं यू हॅव टू टॉस दॅट फ्लोट, आणि एकदा तो रिव्हरमध्ये टाकला इट विल फ्लो, आणि वेन इट विल कम टू द क्रॉस सेक्शन, नियर क्रॉस सेक्शन, and when it will cross the cross section, signal is given to the next observer, downstream observer, and then he will note down the point. Right? The velocity of the float is equal to the distance between the 2 cross section divided by the time. Whatever distance it travel from first cross section to the second cross section, that is known because that we have marked, and then whatever time it has taken to flow from that first to second cross section, it is noted. Then velocity can be determined, distance travel divided by the time. This relationship is used. So this is regarding determination of velocity. Now coming to the dilution method for determination of discharge in the river. The discharge in the river or flow in the river is determined over a length of the stream rather than a single point. So in case of this, instead of measuring discharge at a single point, it is measured along a certain stretch. Dilution method may be used where the conventional velocity area method cannot be used. Wherever it is difficult, to use the conventional method, in that case dilution method is used. The discharge is determined over a length of the stream rather than at a single point. So in case of this, the tracer is used. The tracer is used for measurement of the discharge. A known quantity of tracer is introduced into the stream. So here what is done in case of this, a known quantity for steady feed method, a solution of tracer material, concentration of C1 injected at the constant injection rate Qt at a point x1. So in case of this, as discharge is measured in a stretch of the river, so obviously there will be two sections. We have to select x1 and x2. At x1 we have to inject a tracer of concentration C1 and with the discharge Qt. Qt is the discharge of tracer. The tracer disperses as tracer will get in the injected of certain concentration C1 into the flow. What will happen? The tracer disperses laterally into the flow and tracer concentration distribution is similar to as shown in figure. So what will happen? So at this section, the tracer of discharge Qt will be injected with concentration C1, certain concentrate. As it will flow along with the flow, it will get mixed, its concentration will get diluted, and then at second section x2 the concentration, let it as C2 is measured. C2 is measured, and then this is useful for measurement of the discharge. So at some point x2 downstream, where the tracer material is approximately uniformly mixed, the flow is sampled continuously, the discharge in the stream is calculated as Q equals to Qt C1 divided by C2. Qt into C1 divided by C2. This relationship is used, where Q is the discharge in the stream, C1 is the tracer concentration at section x1, C2 tracer concentration at x2. Definitely it will be different than C1, and then Qt is the constant injection rate of tracer. It is a tracer discharge, rate of the discharge. So with this relationship, we can find out the discharge with the help of this dilution method, or you can say tracer technique. Normally short note is asked on this dilution method. Short note may be asked on price current meter. So hope you understood it technically in a better way. So this is all about measurement of discharge with the help of area velocity method and measurement of discharge with the help of dilution method. Thank you.